Let A, B, C, and D be placed consecutively on a circle, and let W, X, Y, and Z be midpoints of arc AB, arc BC, arc CD, and arc DA, respectively. We want to show that chords WY and XZ are perpendicular. Okay, so first off, let's go ahead and start this proof. First off, we have the setup where the measure, we want to basically prove that the measure of angle ZPW, right, ZPW, we want to show that this measure is equal to 90, because if we can show that this is 90, that means these two lines are perpendicular, right? So, first off, we do know that the measure of angle ZPW is equal to half the measure of arc ZW, right? Measure of arc ZW plus the measure of arc XY, right? So this is the basis that we're going to go about. So here we can see that, for starters, the measure of arc AB plus the measure of arc BC plus the measure of arc CD plus the measure of arc DA, that's equal to 360, right? So notice we want ZW, so let me do this. We want ZW and we want XY, right? Right, we want those two. So as you can see, AB, the measure of arc AB, since W is a midpoint, that means AW is congruent to WB, right? So notice we're only interested in this purple area for ZW, right? So hopefully you guys agree that the measure of arc AB is the same thing as 2 measure of arcs AW, right? Similarly, the measure of arc BC, notice for BC we're only interested in this XC part, and since X is a midpoint of BC, that means the measure of arc BC is just the same as 2 measure of arcs XC, right? And then CD, notice we're interested in this blue part CY, so CD, since Y is the midpoint of CD, this is the same thing as 2 measure of arc CY. And then lastly, the measure of arc DA. Notice we're only interested in this purple part. So the measure of arc DA, since Z is a midpoint of arc DA, this is the same thing as 2 measure of arc AZ, right? So that is equal to 360. So notice now I just have the AW. AW is the purple part. ZA is the purple part. XC is part of the blue part, and CY is part of the blue part, right? So notice there is a common factor of 2, so I can factor out the 2. So I have 2 times the measure of arc AW, and I'm going to put the purples together, right? So plus the measure of arc AZ plus the measure of arc XC plus the measure of arc CY. So I factored out the 2 and rearranged it, right? And that equals 360. So now what I can do is I can divide by 2 on both sides. So I get the measure of arc AW plus the measure of arc AZ plus the measure of arc XC plus the measure of arc CY is equal to 180, right? So now, as you can see, let me scoot down a little bit. AW plus AZ is just ZW, right? So this means that the measure of arc ZW plus, and the measure of arc XC plus CY is just XY. So this equation is the same as this equation down here. The measure of ZW is AW plus AZ, and then XC plus CY is XY. So measure of arc XY is equal to 180. But look at that. I have the measure of angle ZPW is equal to half of the measure of arc ZW plus measure of arc XY. So going down a little bit, I know this implies that the measure of angle ZPW is equal to half the measure of arc ZW plus the measure of arc XY. And ZW plus XY is 180, so this will be half of 180, which is equal to 90. So I've proven that the measure of angle ZPW, which is right here, is 90. So that means that WY is perpendicular to XZ, which is exactly what we wanted to prove. So this implies that WY is perpendicular to XZ, and that is my proof.